Welcome, geologists. We're at Grand Teton National Park at Jenny Lake, and I want you to focus in on the very tippity top of that mountain up there. That's the Teton Range, and you're looking at a glacial horn. Here is how a horn is made. You have to have at least 2, but literally 3 or more valley glaciers, all eroding the same mountain down at the same time. So when did this happen? It happened in the last ice age, known as the Pleistocene. And so remember, you've got to have multiple valley glaciers eroding down the same mountain at the same time to create that type of structure right there. Horns are distinctive proof that glaciers used to be in the neighborhood. There's a lot of other proof that I can show you, but I wanted to focus in on horns at this time. Greetings, geologists from Grand Teton National Park. I'm at Jenny Lake, and I had spotted something cool. We are right here at a glacial erratic. What is that? This hunk of granite that I'm sitting on actually came up from the mountains. In a minute we'll show you what those mountains look like. And they got brought down to the valley via valley glaciers in the last ice age. So these things totally litter the landscapes all over where valley glaciers, otherwise known as alpine glaciers, have traveled in the last ice age. Well, how do we know that the last ice age occurred? This is just one of many, many clues. The mountains are our clues, moraine deposits are our clues, and glacial lakes are our clues, and there's so much more to come that you're going to learn about. But I'd like to leave you with this thought. This granite is 2.7 billion years old, and the mountain it came off of is only 10 million years old. How is that possible? So ask yourself that. Now we're going to show you the mountain, and then we're going to show you something really cool in the background. So get ready and see if you can spot what the surprise is. Be looking for your surprise, because it's right there.
Go.
Greetings, geologist. I'm here at Grand Teton National Park. I wanted to give you a beautiful morning and to take a look at the incredible landscape behind you. You're looking at the Teton Range. A little bit about these rocks. Let's get back to how old they really are. They are 2.7 billion, you heard me right, billion years old. That puts them as Archean in age. Now, the mountain range you see behind me, however, is extremely young. It is one of the youngest in the world, to be exact, about 10 million years old. So the rocks are very old, but the range is very young. How can that be? Let's go a little bit further back in time. About 100 million years ago, we started a series of orogeny. In other words, we had a collision on the western side of the continent in the Cordilleran Range. And what happened was many millions of years of sedimentary rocks have been deposited primarily by oceanic situations, marine rock. All of that got shoved inland and shoved on top of some really old rock like you see here. So when 10 million years ago started, we actually had the Teton Fault got very active and shoved this mountain range up due to a bunch of earthquakes and caused the valley floor to drop. So now we got sedimentary rock at the top of this stuff that's 30,000 feet different from where the valley floor is. That's the same rock. It's really, really interesting stuff. So that's only part of the story. If you take a look at how dramatic the landscape is, that's only happened in about the last 2 million years. So what caused that? Glaciers did. Let's take a look at this feature right here. Look at that mountain and see a U-shaped profile. That's only caused when a valley glacier comes down a mountain. You can see at the very, very top of that, you see what looks like an indentation or a circle. That's called a cirque. Cirques are the heads of valley glaciers and leave a hole behind, kind of like a hole or a bowl-shaped feature. You can also see on either side of that U-shaped profile, you see a very steep ridge. That steep ridge is where you get 2 valley glaciers actually eroding down the same mountain. It leaves behind a distinctive profile. If you take a look over here, you're going to see there's some really steep looking steeple-like structures. Those are called horns, where you get multiple valley glaciers that are eroding down the same mountain. I would also make a note there's an active valley glacier on that mountain right there. That's one of the Glacier Teton events happening right now. And there's one behind me way over here in the background on another mountain right over here. You can really see that trough forming there too in the beginnings of reeds. My point is that this is a remarkable geologic story that started back in the Precambrian eon and continues today. Another way that this continues is the geology provides an ecosystem and habitat for lots of different plants and animals based on the elevation change and the types of weather we have here, precipitation rates. All of that factors into why Grand Teton is such a remarkable place. We will see you at the next stop.